The first step to factoring polynomials is to look at your polynomial and try to factor out a G.C.F. G.C.F. stands for greatest common factor. Let me show you an example. Here I have a 3-term polynomial. I have 8x to the third, y squared, which is one term, plus 12x y to the fourth, which is my second term, minus 20x to the fifth y to the third, which is my third term. I want to look at these three terms and see if I can find a common factor. I want to find the largest common factor. So there's really two steps to doing that. First, I want to look at coefficients. I want to look at my 8, my 12, and the 20. And I want to try to find the largest number that will divide into my coefficients. I want the largest factor of 8, 12, and 20. In this case, the largest number that will divide into 8, 12, and 20 is going to be the number 4. The next step in identifying the greatest common factor is to look at each variable. I want to look at each of the individual letters. So in this problem I have some x's and some y's. And I want to know the largest number of each variable that I can take out. If I have x to the third and x to the fifth, the largest number that they all have in common is actually going to be the smallest exponent. So I want to look at each variable and find the smallest exponent on each. So in this problem, I want to look at my x's and find the smallest exponent on an x in the polynomial. Here I have x to the third. Here I just have x, or we could say that's x to the 1 power, and x to the fifth. The smallest exponent is going to be that x to the first. Looking at the other variable in my problem, which is the y, I want to find the smallest exponent on y. Here I have 2, 4, and 3, so the smallest exponent is the 2. So by looking at the coefficients and looking at each variable, I found the greatest common factor in this problem to be 4x y to the second. That's what I'm going to try to factor out. So going back to this trinomial, I want to divide out that greatest common factor that I just found, which is 4x y to the second. I'm going to divide that factor out of each of the three terms in my original trinomial. When I divide this out, I'm still going to have 3 terms left inside. Because what I'm doing here is creating a multiplication problem. I'm saying that 4xy squared would multiply by this trinomial I'm getting ready to write to give me back my original problem. So let's do the division here. When I divide 4 out of the first term of 8, 2 would be left. When I divide x out of the first term's x to the third, I'm taking one x out. I would be left with 2 x's. When I take out the y to the second, from a y to the second, there would be no y's left in that first term. Then let's divide the 4xy squared out of the second term. When I divide 4 out of a positive 12, I'm left with a positive 3. When I divide x from x, I'll have no x's left. Y to the second taken out of y to the fourth leaves me with 2y. Notice that my third term here, this 20, has a minus sign in front of it. I'm going to treat that like a negative 20. When I divide 4 into a negative 20, I have a negative 5 remaining. And x taken out of x to the fifth leaves me with x to the fourth. And 2y's taken out of y to the third leaves me with 1y. I have now factored this trinomial by taking out a greatest common factor and finding the parts left in my trinomial. Let's do one more thing to this problem. Let's check my answer. If I factor this correctly, then I should be able to use the distributive property to multiply these terms back out, and I should get back the original problem that I started with. So I'm going to use the distributive property to take this term and multiply it by the 3 terms inside to make sure that I come back up with my original problem. 4 times 2 is 8. X times x squared is x to the third. There's no y's to multiply, so I leave y squared on the end of that term. Plus 4 times 3 is 12. There are no x's, so I'll have 1x. Y squared times y squared gives me y to the fourth. 4 times that negative 5 is negative 20. X times x to the fourth is x to the fifth. And y squared times y gives me y to the third. So if we compare that trinomial to the trinomial that I had in my problem, I can see that all of the terms, all of my exponents, completely match. So I've checked my answer. I know this answer multiplies out to give me my original problem. So as long as I chose the largest common factor to take out, then my factoring solution here is completely correct. So the answer to this factoring problem is this step right here, where I took out the greatest common factor and I showed what was left as the trinomial inside.